Okay, class, let's look into a situation where there are two solutions. So we're looking at a triangle we need to solve, and all we know about it is the angle A. Okay, so let's call this A, and we know it's 35 degrees. We have another angle over here, we'll call it B. We don't know what that is, and then C is the third angle that we don't know. But we do know that opposite the angle A is the distance little a of 6. And opposite the angle B is the distance little b equals 8. Okay, so we're not going to chain this together yet because we're just working with the limited amount of information. So let's start off and take the sine of A over little a. So the sine of 35 over 6 has to be equal to the sine of B over 8. Okay, and so to solve this for sine of B, we're just going to multiply 8 on both sides. So I'm going to write the sine of B on the left-hand side here. And that's going to be equal to, so 8 over 6 is going to reduce to 4/3 times the sine of 35 degrees. And if the sine of B is equal to 4/3 times the sine of 35 degrees, then of course B is equal to the inverse sine of 4/3 times the sine 35 degrees. Okay, so let's find that. Some calculators show you your mode up here, and this is in degrees, so I don't have to go check it, but make sure you're in degree mode. And we're going to take the inverse sine, so second sine, and we want 4 times the sine, 35 degrees. And we're going to divide that by 3. All right, so let's round that to this first digit place, and we'll call that 49.9 degrees. Okay, so let's take that down here. We're going to make B about equal to 49.9 degrees. And we also want to look at the possibility of another angle for B, because when we have two solutions, remember that we can either have a triangle that drops down here or down here if this is B. Both of those are B, and they make different angles, so let's check it out. So the angle 49.9 degrees is a little bit more than 45, so I'll just try and sketch it in here a little bit. So let's say that's the point on the unit circle. So it's some positive x value that we don't care about, but the sine comes from y. And if we calculate 4/3 sine of 35 degrees, we get about 0.76. Okay, so for the y, because that's what the sine turns out to be, we got 0.76. And that's going to repeat itself on the unit circle when it whips back down here. And we have the negative version of x that we don't care about, but we still have a positive 0.76. So that's another possibility. We've got this angle at the 49.9, but then this angle is also a possibility. So since we know this is 180, if I take, and these are this counter revolution 49.9 degrees. So if we take the 180 and subtract 49.9, I'm going to get 130.1 degrees. So we have two possibilities for B. So we'll call 49.9 degrees a B1 possibility, and we'll say that a second B could come in at 130.1 degrees. Okay, so here's where we see why that's possible. Because if I take my 180 degree total of the sum of the interior angles of the triangle, and if I subtract off the 35, which was our known angle A, and then I subtract off 49.9, then we should get a result that represents the C that goes along with this. So whatever's left over is the rest of 180 degrees goes to C. So since we got the B1 working in here, we'll call this a C1. And C1 is going to be about 95.1 degrees. Okay, now obviously this result has to be positive. So if I pop over here and calculate 180 minus the 35 and then minus the 130.1, if I don't get a positive result, then I can scrap this method here. But it's going to come out to be also positive, but a very small angle, 14.9 degrees. Okay, so we've got two scenarios to play out here. So we'll take a look at solutions for both. All right, so now let's mock up these two situations so that we can solve both cases. So I'll just call this first triangle, triangle 1, and we'll mark up the other possibility, triangle 2. And A is the same in either case, it's 35 degrees, as is the length opposite A's angle, is 6 in either case. Here we're going to use B1, and that's 49.9. Here we're using B2, 14.9. Now the length B is locked in at 8 in either case. And in this first scenario, we found the C1 that goes with B1 to be 95.1 degrees. And we do not know the length of C for this scenario, but we know the length, we know the angle for C2 is going to be this we call the B2 situation, so C2 is 14.9 degrees. Okay, so C2, 14.9. And we don't know the little c, so I'll distinguish those because they're going to be different for each case. Alright, so now we just need to use the law of sines to find the length C1 under case 1 and the length C2 under case 2. Those are the only ones that are left unknown. So what we can do then, of course, is just apply another law of sines, and I want to use as much of the exact information as I possibly can. So we started out with an exact value for angle A, an exact value for the length A. So we'll set that up and say that, okay, along with that, we have to have the sine of 95.1 for C and C1. Okay, so just solve that for C1 the way we've been doing it, and then over here we'll set up the left side the same way. In this case, 14.9 creates the length for the second scenario, so little c2. Okay, and if you remember how this goes, if we cross multiply and then divide by this numerator on the known quantity, so we'll just take C1 is equal to 6 times the sine of 95.1 divided by the sine of 35. And we come up with a length in this scenario about 10.42. Okay, and then in this scenario, C2 is going to be equal to 6 times the sine of 14.9 divided by the sine of 35. And that comes out to be about 2.69. Okay, now I've included a nice little mock-up of each of these results just so you can visualize what happened here. So no matter what, we've got an angle A here of the 35 degrees, and then opposite A we have either a 6 that falls back here or a 6 that pushes out here, and then that scenario creates a different one. So if my angle for B1 was 49.9 and my fixed length is 8 in this case, and the other possibility is that my angle for B2 could be down here, and then we've got the fixed 8 across from that as well. So both the 130.1 degree angle work for B and the 49.9 work as well. And then of course the corresponding C's with each situation. All right.